So in this lecture I will discuss something about the work done on the system, because it is kind of confusing concept in thermodynamics. So we start with this with the formula that we will use. The formula is dW is equal to minus P dV, and this is for the differential work. Because you know in thermodynamics when you do a process from the beginning to the end, there is I mean a lot of change in the properties. So you cannot take all the way at once, means in one calculation. You have to break that path into very small paths, and then you have to put some formula or mathematics in that small part. After then you have to apply the integration concept that you are aware in mathematics. So anyways, the formula is dW is equal to minus P dV, and now what is here dW? It is the work done. This very small amount of work will be done on the system, and P is when an external pressure P is applied on the system, when an external pressure P is applied on the system and it brings dV reduction in the volume. You can means it's very important, it brings dV reduction, means the volume will reduce, the final volume will be less than the initial volume, and P is what? It is the external pressure. It is not the pressure of the gas, actually it is the external pressure or the pressure that is applied by some agent. And if you are compressing the gas, then what pressure you are applying on the gas, that is the external pressure. It's very important point actually. And second point is also very important, when the external pressure is equal to the gas pressure, then the gas pressure can be used here. If this I am showing you this figure, if you are applying a force from here or pressure from here, then your force, if it is equal to the gas pressure is something else, it is not the external force, then you can take this gas pressure equal to the external pressure. You will understand this thing in the latter part of this lecture. Now I come to the equipment used in our analysis or whatever numerical you will do. What equipment you will use to study the system? The equipment will be used to study the system, and this equipment will be used to study the system. There is the gas is your system in a cylinder, it is just a cylinder, and at the upper part this is a piston, and it is frictionless and weightless. Important point, it is frictionless, it can move very freely without any loss of energy or without any heating or kind of things, and it is weightless. Outside there is vacuum, there is no air here. You can imagine all these things. The pressure gauge here, this is the pressure gauge, simple pressure gauge that is used to measure the pressure of the gas. Just for example, the gauge that you use to measure pressure in a tire pressure in vehicles, so the same pressure, so it will tell you the pressure of the gas, and here you will apply the external force. So now the question is how to create certain pressure in the above equipment. Suppose you want to create some pressure that you want, actually how you will create that pressure. Suppose you want to create you have been asked to create 2 Newton per meter square pressure in this equipment, in this gas. How you will create that pressure? So for this you will take a weight, a simple weight, and you will take what quantity of weight you will take? It will be taken such that it will create 2 Newton per meter square pressure here on the piston. So what is the weight of this? Suppose for example its weight it is 10 Newton, and the area of the piston is 5 meter square. Then divide in per meter square area how much pressure it is creating. It is 10 divided by 5. So 2 Newton per meter square. So this is nothing. This pressure is just force, and at what area, what force is being applied, that is pressure. So this is actually creating external pressure on the piston here, and accordingly the gas inside will respond that way, because if the gas is at this point here, the gas is at less pressure than 2 Newton per meter square, then it will be compressed. And up to what point it will compress? So here you will see the pressure will increase. This piston will go down, and pressure of the gas will increase, and it will increase until the pressure of the gas reaches to the outside pressure. So that time this piston will stop moving, and the system will come at equilibrium, and the pressure of the gas, you will see, it will be 2 Newton per meter square. So here you see, this is the you have applied here 2 Newton per meter square force from the outside. The gas pressure is less than that, so the piston will move, because the forces are not in equilibrium. So the piston will move down, and then here, when the forces will come in the equilibrium, it will become stable, it will not move, and then the pressure of the gas will be exactly the same, the pressure that you have applied from the outside. So the piston will stop when the pressure of the gas reaches to 2 Newton per meter square. In the same way, any desired pressure can be generated in the gas. So actually this is this equipment is there in the laboratory. It's not an imagination. It is called a dead weight pressure gauge. Just with the weight, with weights, you can create the desired pressure, and this equipment will be used to solve our thermodynamics problems. Now I come to the numerical problem, so that the concept is clear. Okay, I think that I can take it in next part of this lecture, because I want to keep the size as small as possible. So in the next part I will discuss this question. Okay.